What's up, everybody? Let's get some chapter 19 done. Hey, guys, looking all crazy. Crazy. Chapter 19. Who wants to do chapter 19? Simon Manager. Zariah, good to see you. Is he in person? Tomorrow, 9:30 is live on YouTube all day long. I think I'm going to do, so that way everyone can view it. Does that make sense? Because the YouTube, since it'll be a big review, and then we will do the Pearson. But does that make sense, Zariah? Like live on YouTube all day right there. So we won't do in person. I'll send an announcement about that. That way, get a lot of people viewing it, get a lot of help out there. That's kind of my goal. Have you already done the chapter 19, Zariah? We could do the full homework right now. Get that done. 9:30 will be online. So because my classes got canceled. Woohoo! My classes are canceled tomorrow, so I am going to, and we can do the homework right here. So my classes were canceled. We're done with my classes. So since my classes are canceled, I'm like, why don't I just do office hours? It's what I did last week with the with helping out with the project. Because last week my classes were canceled. Well, one of them technically wasn't. Haha. Found that out a little bit late. But I had already told them, I'd already told you guys we're having office hours. So I was like, well, if I tell you we're having office hours, then we're going to have them. So Stat 201, Chapter 19, Homework Question 1. Let's check out the first question right here. Get it done. Oop. First thing. Good question right there, Ramo. Check out the review page. It has the review documents. Good questions right there. It has everything we will be going over on the test. Review 3, Mubot will be dropping it. Click there and check out the review documents. Good stuff on the review page. Has everything covered with practice test questions. So how do we do the null? Review is Thursday. Oh, it's not tomorrow? Well, that's good. Then we're not colliding with it. So how do we write the null for this? How do we write the null? When you see things like injury site and lethal, how do you write the null for the chi-squared test of independence? How do you write the null for the chi-squared test of independence? So how do you write the null? Remember our trick? You just have x and you have y. So how do we write the null? How do you write the null? How do we do it? How do you write the null? Well, it's the chi-square test of independence. So that makes writing the null really easy. How do we do it? How do we write the null? If you know the trick, you can do it in seconds. So all you have to write is that injury site is independent. Remember the chi-square test of independence? So the injury site is independence of the lethality. Exactly, John, right there. Great work, John. So you just write the two things are independent, and then you do it in a full sentence. Like if you had to write it out, you'd say injury site is independent of it being lethal. And not related is true also. Usually, I like a lot of times on Pearson, they do use the idea of like they are independent. So you see they are independent, and the alternative is they're not independent. So the null is just that they're independent. Now we get to the expected cell counts. And the expected cell counts are from the formula row total times column total over grand total. So we would have to take this table right here, and we can do it, and find all the expected cell counts. So to find the first one right here, it's going to be this times this over this. And look at how it crosses in on this number. That's going to be the expected cell count for that cell, so we can solve them all out. Now, there is a trick that I'm going to do on this. So it'd be 119 times 69 over 149, and that's 55.11. So I'm going to do a trick right here, 55.11. And then the next one, all you have to do is move down to this. So now you're going to use these numbers right here. And there's the row total times column total over grand total. Yeah, it doesn't matter too much, Jesse. Great question. It's kind of x is independent of y is independent of x. True. Good answer. And great job. Thank you for being here. We should be able to get this done. And now notice we have two of these values, 35.94. 35.94. What we can do is we can actually solve for the other values because there is only there's only 2 degrees of freedom, so we can now do forced choices. So since we know this has to add to 69, and this has to add to 45, then this one right here must be 9.06. I'm just cheating by finding if you take this number right here and do 45 minus it, there's the number. And then we know that this has to add to 69, so you can just go 13. I think it is 13.89. And who follows me? Type yes in the chat if you follow, because you can solve each one out using the formulas up above, or you could take 69 minus 55.11, and there's that number. Then the last, these have to add to 30 on the bottom. You know that logically, and 119. Once again, you can always find these. You could solve for the one in this cell right here by taking the values right there and doing row total or column total over times total over grand total. But you could do that, or you could do my trick. Either which way works. Rock knows. It doesn't matter as long as you know how to get these values. This is the way you would do it mathematically. And 149, so that is 27.95. And something seems a little bit weird about that number. It seems 27.95. You see, that's a 9% difference. I feel like something's a little bit off. Let me see. No, I did that one. Huh. What is 55.11 plus 35.94? And then, oh, well, I'll be. Okay. Just trust it. Okay. And then last but not least right here, 35. Is that what we want our over the grand total? True. Row total times column total over grand total. Exactly. And 35. So this must be 7.05. And then you can find that value. If you want to find it mathematically, you can just do row total times column total over grand total. And so you can solve for that 7.05 with 35 times 30 divided by 149. And there's the 7.05. So there are all the expected counts. So we got them all. So many calculations. And so let's go show. Here we are. 2 decimal places. 55.11. 13.89, 35.94, 9.06, 27.95, 7.05. There we go. Got it. And then now it says, now it jumps straight to compute the chi-squared, which is, whoa. It's a lot of work. So what we have to do now is we have to go back to our sheet of paper right here. And this is really good practice for the test. Like if you can do these, you know how to do it. And you get the formulas on the test. So this all right here was row total times column total over grand total equals expected. Now we want to do the observed minus expected quantity squared over expected equals the cell chi-squared. And so we need to draw another table here. And there's our table. Really? And now we draw that. Lines. There we go. And now we have to do observed of 62 minus expected of 55.11 quantity squared over 55.11. And then we do observed of 44 minus 35.94 quantity squared over 35.94. And you see we're just taking the observed, which the observed are these up here. So these are all the observed. And then the expecteds are all of these values. That's the wrong color. The expecteds are all the values we just solved. So they get plugged in. Is this making sense how to do this with the numbers we have on the screen? You just do it for each one. It has to be the right cell with the right cell. So you would take observed of 13 minus 27, that's not 27, 27.95 quantity squared over 27.95, observed of 22, that's the bottom right cell up top, and then minus 7.05 quantity squared over 7.05, and then this one is observed of 1 minus 9.06 quantity squared over 9.06, observed of 7 minus expected 13.89 quantity squared over 13.89. So that has it all, and I'm just going to solve each one off the screen now. And what you need to do, well, this is where it gets less fun. I guess I need to keep this on the screen. Is you have to find all these and add them all up. So let's make one more grid over here where we can add them all up. And we need to write down each one. Okay. So 62 minus 51.11 quantity squared divided by 55.11, 0.86. And I think there's a little bit of leeway on this, but 0.86. I would do to 2 decimals while carrying it. And then observed of 44 minus 35.94, and then quantity square divided by 35.94, 1.81. And then here, 13 is observed, minus 27.95, and then quantity squared divided by 27.95. Is that really right? It might be. It's basically 8. That should be a very big difference. Yeah, I guess so. Yeah, it's a bigger difference. I guess it is. We'll trust it. Hopefully we didn't make a math error. And observed of 7 minus 13.89, quantity squared divided by 13.89, and 3.42. Observed of 1 minus 9.06, negative 8.6, divided by 9.06, and that's 7.17. Losing my pen. And then 22, observed of 22 minus expected 7.05, quantity squared divided by 7.05, 31.70. Now you must add these up because you take the cell chi-squareds and you sum them up and you get the Pearson chi-squared test statistics. I ran out of room right there. Pearson chi-squared test statistic. So we have to add up all these cell chi-squareds right there. So we're going to go plus 7.17 plus 3.42. We already had the first one stored in there. Plus 8, beautiful, plus 1.81 plus 0.86. And that's the Pearson chi-squared test statistic, which is the sum of all the cell chi-squareds. 2 decimals, so let's cross our fingers. I carried enough decimals, and I did. Now, here's the thing. How many degrees of freedom? This is an easy question. This chi-squared has 2 degrees of freedom because, Brian, this is a 3 rows, 2 columns. Delete 1 off each, you get 1 times 2. One of the quickest ways to do the degrees of freedom is to simply draw the L on your graphic, which will delete 1 row, delete 1 column. And if you delete 1 row and delete 1 column, you can see the 2 degrees of freedom. You can draw it anywhere, just don't include the totals, but you get the 2 degrees of freedom right there. If you do it here, you make a mistake because you're not using the totals. You're looking at there's 3 groups here and 2 groups there. So that's the 2 degrees of freedom right there that you have. So there are 2 degrees of freedom on this chi-squared, which shows us the shape of the chi-squared distribution. So you can see right here, the shape would look something like this. And now the p-value, we can think really hard, and the p-value is going to be 0. So how did I know that? Well, you saw the chi-squared for a millisecond right here. You saw it over here. And we landed at like, what did we land at? Like 39? What was that value? It's off the scale. 53 rather. So we're going to find the p-value, and 53 is not even on here. 53 is way off this graphic. So if you actually look at the p-value, it's that. It's a lot of zeros. It'd be 0.000000000000309 about. And so it's a very, very tiny p-value. No need to interpret chi-squared graphics. We don't have you use applets on the test. And then we wouldn't have you use anything. The Canvas content, number one way to know what the test looks like. So good questions, Araya. So what should we do right here? Reject the null or not reject the null? Well, the p-value is low, reject the null. And we're doing this, and we would say we have evidence for the alternative. We would conclude that they are not independent. So is way less than, we reject the null because the p-value is way less than alpha, and conclude that injury site and whether or not they are lethal are not independent. So we have evidence of dependency. Well, that's got it. That was a good one right there. That was a good, tough question. Oh, yeah. Oh, here, wait. 1 second, Jay. Be right back. Zariah, of course you are. They're at the front desk. When you walk in, anyone wondering, they're at the front desk. So swing by the front desk. Really had a great time. Talked to Jay for a bit right there. Talked about gardening and all this stuff. I tell you, I am always shocked at the amount of students who are into gardening and just doing things outdoors. A lot of good fun. A lot of just good energy. Does like go out and do stuff. Go out and build a garden. Grow a garden. It's a lot of input. A lot of you got to get a lot of work done at the start, but totally worth it. Totally worth it. And Jay mentioned a video where a guy was making his own chicken sandwich from scratch and it cost him like $1,500. But of course, then you're invested in it, and the chicken sandwiches cost a lot less. The initial chicken sandwich is the expensive one. Sheets, good to see you here. I love it. We got one of the brothers, Isaac and Nathaniel. Sorry, Brian is the Stash Lessons. I just saw your first pitch of the Smokies game on the channel. Thank you so much, Sheets, right there. You know what? Let me plug your channel really quick. I'm going to go to Sheets Music, and I'm going to show the Titanic video, and then we're going to do a little more stats. It's the end of the semester right here. I'm having a little bit of fun. But let me go. Do you mind if I plug that? I don't think you'll mind. Sheets Music. Here we go. Wait, that's not your channel. People are copying your channel. Let me type Titanic. Of course. I like it. So here we go. Wait, you might need to drop the link for me. Drop the link real quick. Playing the Titanic at Titanic. I'm not going to find it now. Why can't I find it? I should be able to view your channel. Go to channel. There it is. Okay, here we go. Found it. 7 years ago. Oh my gosh. Here we go. Popular. Yes. I played... There it is. You got some big videos. Your videos are pretty popular. Do not copyright strike my channel. Let me drop it in the chat, though. So that way you can get the views. So here we go. Titanic video. So you can get the views. Yeah, so check it out. That is some good cinematography right there. So awesome stuff. And good luck to everyone there. There's the man, the myth, the legend himself. Gosh, it seems like yesterday to me. Seems like yesterday. People were in my class. I get to teach so many amazing and awesome students. That's why I guess I'm just so happy today. Like, and then I always see you around campus and you say, hey. I make too many jokes. People think I'm serious all the time. Isaac was the one that was opening the door at the beginning. Really? Isaac was? That cracks me up. I like that. I hope Isaac... I haven't seen Isaac in a little bit. Usually I see him when we do, some company stuff. So I hope to see Isaac around. Always good seeing you both. So you guys are always really nice and positive. So, I mean, it's sad things. But with that, let's do a little more Stat 201. Everyone's just so happy today. It's just a good day. Chapter 19. This one's a really easy question. Homework question 2. So this one is a little tricky. You can get it right by just guessing it because it's a homework, so you can do multiple guess. But the null hypothesis is that the two things are independent. Which of the following would be an appropriate alternative after rejecting the null? And usually we like to say they're not independent, but we don't usually say they depend on one another. I know it's like, wouldn't you say that? Well, it more means that they're associated. I do have my qualms with the way this is written, but it's such an easy question once you see the answer. And it does let you know the idea that we often say when two things are not independent, they are associated. So, and Zariah got it right there. Nice job. You got it. And now we get to here we'll do question 2/3 for this. For all the chi-squared test of independence procedures, the sample size assumption is checked by the what condition? It's weird this is sample size, but in Zariah's got it. It is expected cell count frequency. All the expected cell counts are larger than 5. So that problem we just did previously, all of these values were greater than 5, so we pass. You would just look at these values right here. They're all greater than 5, so you pass it. You're good to go. Success failures for proportion tests or proportion intervals. Nearly normal is for quantitative Mr. T tests. So it is the expected cell count frequency. Let's try this next one. Zariah, are you doing well today? How's your day going? Stat 201, Chapter 19, Homework Question 4. A certain story describes a long war. Wait, the first box is greater than 5. Wait, it is? Oh, I think you might have been talking... They all need to be greater than 5. That is true. All of these need to be greater than 5. Good to hear. Glad you're doing amazing. So it passes because all of these are greater than 5. It's not the observed. It's the expecteds are all greater than 5. So we pass. And so with this one, the null hypothesis is that they're independent. Remember, you just take right here and write that the two things are independent of each other. So all you do is go between them and write the word independent. That's it. This weapon is independent of injury site. It means, like take an arrow to the knee. Is that what that dude did in that movie? But what weapon hits you is independent of where you get injured. It wouldn't matter where you got injured. Wouldn't tell you anything about the weapon used. The alternative is going to be that they're not independent, so the null is independent. The alternative is not independent. Remember, we're doing the chi-square test of independence. The null has in it the word independent. Good way to memorize it. Now, this one has a lot of expected cell counts. I'm going to show you how to do this one in Excel. So give me a second. We're going to pull open Excel. It does make your world a little bit easier. Do remember that this video is recorded, so if you want to see how to do this, you can always slow down, rewind the video, and let's show how to get this done in Excel. So to do this in Excel, we're simply going to go over here to the question, and we're going to copy the data. So here we go. We're going to click on this, and then copy to clipboard. You could open Excel too. Now hit Command-C or Control-C to copy. Close out of the data. Go back to Excel, and I don't like the top left cell. I usually click around here and paste. Here's your table. Now what we're going to do is we're going to call this the observed. Below it, we're going to make the expected, and we're going to paste it in, but delete the values for the moment. So now we have a spot for the observed, we have a spot for the expected, and while we're at it, let's put a spot for the cell chi-squareds, which are a measure of how unusual each cell is. So now we have the observed, the expecteds, and the cell chi-squareds. So the observed is what you see. I saw 2 people get hit in the body with an arrow. I saw 2 people get hit in the limb with an arrow. I saw 62 get hit with a sword in the body. That's what the observed means right there. To get the expected, we actually need the totals. I'm going to make a little more space by clicking here and going to Insert. Oh no, Jesse, that's all right. It's the same. It's actually probably better. You know what, Jesse? Let's throw you 100,000 points. Jesse, it's probably better to practice by hand. It can be more consistent to do it in Excel, but on the test, you can only do it by hand. So you can solve all these by hand. It's just a little more practice. Notice I'm just going to equals sum, and then I'm going to sum up these values right here. So equals sum and the values. You can copy this across right here because it's going to find the sums. Next, we're going to do equals sum, and then we're going to copy the values across here, and we see it should be 11. We're just adding up those values by summing them up. If you copy this down, it'll copy across and across there. So we have the sum of these totals right there, which is the grand total. So now we have the column totals, the row totals, and the grand total. So each of these cells is going to be, it's going to be row total, notice that's the row total for this one, times column total, divide by grand total. Now the grand total isn't going to move, so we're going to lock it in place with dollar signs. Dollar signs makes it so the index doesn't move. So then when we go to the right here, we don't want this one to move to the right. We want that to stay. So actually, you know what? Yeah, so we want to stay on G. So we need to lock this right here. And then when we go down, we don't want this to move. So I think we need to lock the... Let me double check. We could just do this and copy across. We don't want this one to go down, so that needs to lock on the 7. Yeah. That can't go any lower. So I'll pause with this written right here because I'm pretty sure that should do it. Because when we go down, we don't want it to go down further. But when we go to the right, we do want it to go to the right. When we go down on the G4, we want that to go down. So this is the formula right here. Make sure to put the dollar signs on the G, put the dollar signs there. And then when you copy, what you should see, copy, paste, paste. If you click on any of these now, you should see that it lines up with the right ones. Notice how that, you could just do each one individually, but if you put the dollar signs correctly, you'll see how it lines up. Like, see where that 2 is at? It's with limb, ground, rock, limb, ground, rock. And that's because we did the dollar signs right there, and this lines up right there with the multiply, grand total. And so now we need the cell chi-squareds. We can do a very similar formula right here. We're going to do equals. Actually, this one's even easier. So we're going to do No, Zariah. I'll show that again. Remember, you can pause the video. So this is going to be observed minus expected, and then quantity squared divide by expected. That should do it right there. Observed minus expected. So there's the formula. Observed minus expected divide by observed minus expected quantity squared divide by expected. And it should be easily able to move around right there, just like that. Notice that I click here, and you should see observed minus expected. Observed minus expected. Look at the color coding. Quantity squared over expected. The previous one up here is the following. And Zariah, you could just do each one. Notice how I'm going to delete this one away right here. And this value would be, we can do equals row total times column total divide by grand total. Yeah, and it's really good practice exam by hand, exactly, if you solve all these out. So here, we'll do one by hand right now. You ready? We're going to solve for this value of 57 right here. So the value of 57 would be solved by doing row total times column total over grand total. So that's how that 57 is found. So we need to make sure we do 127 times 67 divided by 148. And there's the value. So, excuse me. Excuse me. Oh, yeah. Really good practice. And then this makes sure we get it all correct. Now we get the Pearson chi-squared test statistic. And the chi-squared is the sum of all these. So we need, I don't even know how to do a summation symbol anymore. There we go. That's a good enough summation. So the summation symbol, thank you, Zariah. And Zachariah, good to see you there. So the summation of the cell chi-squareds is equal to the chi-squared called the Pearson. So this value is simply going to be, I think we can just do equals sum of these values here. I think it can do it like that. There we go. Oh, no. That's not right. No. So is it, why won't it equal the sum? Here, we'll sum up each one. Okay, so we want to sum up these values and equals sum. Usually don't sum it up like in columns right here, but there's that. There's that. Good. And then equals sum of these values. And there it is, 13.9705. Was it 13.97 but negative? I don't know why I would do that. So 13.9705. So we've now done the full test, and we got the chi-squared. How many degrees of freedom does this have? Who can answer how many degrees of freedom this has? It's a 3 by 3. So how many degrees of freedom does it have? It's a 3 by 3. So how many degrees of freedom does it have? Because we basically did the full test. It has 4 degrees of freedom. 3 by 3, drop one finger, 2 times 2, 4 degrees of freedom. And I really love this chapter because when you get these down, you're like, I can solve them all. And gotta solve them all. Oh, opening jump. No. Okay, go away. Cancel jump. Wow, I can't believe the license that expired. Okay, so now it wants these to 2 decimals. I wish you could just paste in all your answers. That'd be so nice. Like, maybe you should do it twice. Okay. 4.98, 3.64, 2.38, 4.53, 3.31, 2.16, 57.49, 42.05, 27.46. I think we've done it correctly. We did. And then the chi-squared test statistic is 13.97. The p-value is going to be very small. It has 4 degrees of freedom. I'm going to guess the p-value, but I'm probably going to be wrong. Great job, Brianna. Because the distribution is like rightish skewed right now. Oh, no. Nope. Okay. So to get the chi-squared p-value, we need to pull up the chi-squared distribution. And I was just taking some guesses right there. I thought it'd be pretty small, like reject the null. We have to take this chi-squared value. It might be even smaller than this. I should have guessed about there. And so here's the chi-squared applet. And it has 4 degrees of freedom, which shows us the shape of the distribution. And then we type in 13. We find p-value. Make sure to find your p-value. Oh, I should have went really small. and above. I don't know how I click below. Oh, did I get it right on my third guess? No, I was close. 0.007. 0.007. Once again, let me show those steps. I might have been close enough. I don't want to miss it. So, yeah. Once again, you have to enter in the degrees of freedom. Then you have to enter in find p-value using x, because you're going to find your p-value using chi-squared. Enter in the chi-squared value and graph above it. Then round to 3 decimals. And that will get you the p-value for the chi-squared test. Which ones will not be given p-values? We would not ask you to solve this on a test. You would be given it or something. We'd tell you, like, the p-value is 0.007. What do you do using an alpha of 0.05? Well, the p-value is below alpha, so you reject the null. When the p-value is low, reject the null. This means we have evidence, or we do conclude, that they are not independent. So we conclude we have evidence that they are not independent. So how are the degrees of freedom found? 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 A, B, C. It is the dimensions. Remember, yeah, great job, Penelope. Remember, we just said it was a 3 by 3. Well, then that means 2 times 2. So exactly, great job, Penelope. Yeah, rows minus 1 times columns minus 1. Exactly. It's not the level of significance. That's alpha, and sample size is just how many people we talked to. So we did it, and now we got the last one. Woo! We're done with the homework, and the homework and the quiz are virtually identical. So here's the last one. And then we can do the Canvas content. Oh my gosh. Okay. What word is associated with the chi-squared test of independence for the null? Remember the null? What do we write for the null? For the null, we write what? We've got age group and pregnancy. Like outcome pregnancy. There's the Canvas content use Juva Verite quiz. That one I can't really help with. It's easy. Well, so it is a hypothesis, but remember we're doing the null has what word? What word do we write between these? So when you write the null hypothesis, you write what between these? So you have age group and pregnancy outcome. Whether it was early term, like they had it before 36 weeks or so. I don't know, is that early term? Age group is independent of pregnancy, exactly. So you just put the word independent between these, and that is going to be the null. These two things are independent. Difference usually goes to chapter 17, where we talk about differences between the means. This one, it would be that we would say age group and the outcome of pregnancy are independent. The alternative is that they are not independent. Independent would mean, doesn't really matter your age group, you're going to have about the same outcomes. Notice that this jumps right into it. It jumps right to what is the chi-squared test statistic. And there's a lot of steps. They're like, hey, don't even worry about computing those expected values. Don't even worry about computing those chi-squareds, those cell chi-squareds. What we can do is we can copy this to the clipboard, hit Command-C or Control-C, and we're going to bring it back over here to our Excel worksheet. Check out the previous problem where I filled all this out. So what we have to do is we have to take our work right here. Actually, let's just do a new one. You ready? Here's how to do it. Copy it 3 times. We do it 3 times because we're going to have the observed, the expected, and the cell chi-squareds. So this is going to be what you saw, which is already listed there, called the observed. Next, we're going to have the expected, which we'll calculate in a moment. Then we're going to have the cell chi-squareds. Good to see you, David. And we'll have this done here soon. So to get the observed values, we also need the column and row totals. To get those, type equals sum, capital sum, and then highlight the column, and then close the parentheses. So there's the code, and click enter. Do the same thing for the other ones by typing equals sum. You can double click it, and then highlight, and there you are. You can actually, after you write one of these and write equals sum, you can copy it because it's going to copy the same function across. Notice that when you highlight this, it shows you right there what you're doing, and make sure the numbers add up. Now you have the sum of the rows and the columns and the grand total. So now we want to get the expecteds. Know how to solve this by hand. Expected cell counts are going to be row total times column total over grand total. So notice that formula, row total times column total, exactly Control C, Command C, Control C, Command V, Control V, and over grand total. So we're going to delete these out because we don't need them. And then we're going to do equals, and we will copy this in a moment. So we're going to go row total times column total. We need to delete this. Okay, chill out, chill. Okay, we're going to go away and delete that. And then we're going to go here, equals row total times column total over grand total. And this time we'll just do it each one. So row total times column total divided by grand total. Or you can use the way, you could do each one, or if you freeze the last one, the dollar signs make it so it doesn't move. So I froze that. Notice that that's frozen. You can see it up here. And then we don't want E to move down, which means we need to freeze the 8, or E8 to move down. We don't want that to move to the right. So we want to freeze the G on this. That's how to freeze it. So you freeze the G, freeze the first one on the letter, freeze the second one on the number, freeze the last one on both. So that means when we copy this around, you could also, you could round the 2 decimals to make it pretty. But that has got it nice and good right there. 2 decimals is fine. But does that look good, Zariah? And then you can check your work to make sure it's computing in the right cell. Now we need to find the cell chi-squareds. The cell chi-squareds are observed minus expected squared over expected. So observed minus expected quantity squared over expected is the cell chi-squared. So we have to do equals observed. Notice I'm going to the observed for that one. Times expected. What am I doing? I was thinking I need to put in parentheses, and I was like, multiply it. Observed minus expected quantity squared over expected. And so that's got it right there. You can see the formula. We did observed minus expected quantity squared over expected. And now you can actually just start copying these around. Are you holding shift to select multiply? Not holding shift. Oh, to select multiple. Yes. Click here. I read multiply. And then hold shift and click here. The rounding won't be that big of a deal on these because we're going to be adding these up. It can just make it look pretty. And you can do 3 decimals. And then to get the total Pearson chi-squared test statistic, we need to take the sum of this. So the sum of this equals the chi-squared Pearson chi-squared. So that would be the Pearson chi-squared test statistic is the sum of all the cell chi-squareds. So we're going to go right here and say equals sum. And then we're going to add this up. And then there you go. So that is the sum, 2.658. And that is the sum of all the cell chi-squareds. So 2.658. And this p-value is going to be rather large. There's only 3 degrees of freedom. So 3 decimals. This is a very hard guess. If I get this, it would be amazing. It's a very hard guess. Yeah, that's very hard to guess. So it doesn't ask you the degrees of freedom. I wish it did. But since this is a 4 by 2, it has 3 degrees of freedom because 4 by 2, drop one finger on each hand, 3 times 1. It's rows and columns, 4 rows, 2 columns, like 4 rows up top, 2 columns, delete 1, 3 times 1, 3 degrees of freedom. This tells us the shape of the chi-squared. And so the chi-squared has 3 degrees of freedom. And then, need to reload the app right here. Oh, there's no, oh, okay, then yeah, well, darn it. Let me delete that from the video and might go get an energy drink here soon. Okay, you're right. I think you're right, Zariah. Great work. I totally, and then we need to go grab that chi-squared. That's why you're saying there's no other ones. I was like, wait, what? Jujuba Verde? And then find p-value, and we're going area above it. So that was, darn it, 2.447. My first guess was better. That was my first guess, but it was actually 477. So you don't use your guesses. But here's the thing. If you've already done this problem, well, I got that one better by guessing. If you've already done this problem, you should be able to speed run it. because they are independent is the null. And then the chi-squared test statistic right here, we should be able to copy it. That's all right. I'll get an energy. So take a look. If you've already done these problems, you can just go right here and paste in the data. And then you see it went to 2.27. So 2.2777. Check the number. You know why? I was just meant to guess this answer. Because now the p-value is going to be even bigger. And let's go here to 0.589. Oh, well, then I lost a guess right there. I'm going to guess that. Watch it be right. Darn it. So 2.277. 2.277. Oh, man, my first guesses were close. Maybe I should have just kept what I originally guessed. And so that should do it. And then the p-value is greater than, way greater than alpha. There is insufficient evidence for the alternative. The p-value is greater. Does that make sense, Soraya, right there? We have such a high p-value that is way greater than the 0.05 necessary level to reject. We do not reject the null. We do not have evidence for the alternative. It looks like the outcome of someone's pregnancy is totally independent of their age group. But that's got it. And the great thing is if you've done all this work, you can just take these problems and copy to clipboard and just drop them into Excel and be like, well, there we go. Because any of these numbers I change, well, wow, you see that totally, it's like, wait, one individual that is totally unexpected. You're like, there's a ridiculous chi-squared. You can see as you manipulate the numbers, it changes what the values are. Well, we're going to take a break. I'm going to get an energy drink, but this has the homework completely done. Every single quiz question is done. If you can't find the video, let me know. Until then, bye for now, everyone. Bye.